Hi everyone, this is the first half of the 7-4 Big Ideas. The second half of this worksheet we will do live together on Tuesday in a Google Meet as usual. Let's get started. So for number 1, it says we're going to use the given vectors that are drawn for u, v, and w to graph the given vectors that they are asking for. So we're going to start with u plus 2w. Whatever vector is given, we want to sketch that, and u is just u. There's no number in front of it, no negative. So we want to look at u, what we were given, and you want to pay close attention to where it starts, where it stops, and its rise and run, kind of like its slope. Vector u here just goes up 2 units. So you can pick any arbitrary point. These are just kind of floating around in space. There's no axis we're plotting these on. And we're just going to go up 2 units, and that's our vector u. From there, we're going to add 2w. To add 2w, we're going to the end of vector u attach 2 w's. Now w, the original vector, goes down 2 and left 2. So when we say 2w, we're going to do that twice. It's important when you add vectors that wherever your first vector stops, your next vector starts. So where u ends is where w is going to begin. So there's 1w if I go down 2, left 2, and we're going to do 2 w's. Put my arrow at the end of it. If you don't have an arrow, you just have a line segment. It's not a vector, so you would lose points on a test or a quiz. Once you have all your vectors drawn end to end, you find the sum by creating a vector that starts at the beginning of your first vector and ends at the end of your last vector. So the initial points should match up, and your terminal points, your arrows, should match up. So that vector in green is the summation vector u plus 2w. And if you want to check the one on your paper, from start to finish, that vector should be going down 2 and left 4. So that's what I would be looking for if I were grading this, that yours has the same length and the same slope as mine does. Okay, let's move on to the middle one. For this vector, we're going to start with 2v. So let's look at vector v here. Vector v goes down 1 and right 3, and we want to do 2 of those. So again, pick an arbitrary point to start. If I go down 1, right 3, that's 1v. I want to do it again. That's where it ends. That's my 2v. So you can double check that vector should be going down 2 and right 6. We just doubled those movements. Then we want to add on negative w. That's how we're going to think of subtraction. We're going to think of it as plus the negative, or with vectors we often say the opposite vector. Vector w goes down 2 and left 2, which means the opposite of w would go in the opposite direction, up 2 and right 2. You'll notice these vectors look exactly the same. Really, the only difference is the arrows on the other end. The initial point and the terminal point have switched. So we're going to attach that vector, and it looks like I might run out of room here, so I'm going to move this over a little bit. Let's see if I can move my 2v over. I have to do it in pieces. That's okay. There it goes. All right, so w is going to start where 2v ended, and this time we're going to go up 2 and right 2. So that's the opposite of w. And then your summation vector will start where the first vector started and end where the last vector ended. So your vector is actually going to look horizontal here, and it's going to the right 1, 2, 3, 4, 5, 6, 7, 8 units. And that's the vector 2v plus the opposite of w, or 2v minus w. Okay, so now we're going to put 3 of them together. Again, remember, we're just going to do end to end with these. We're going to start with 3 w's. So 3 w's would take me down 2, right, left 2, and we're going to do that 3 times. There's 3 W's end to end. From there, we're going to add on half of U. Well, U, remember, was 2 units long, so half of that, we're just going to go up 1 unit. So that's 1/2 U. And then from there, we're going to add on the opposite of V. Get my colors so they all match here. So if V originally goes down 1 and right 3, the opposite of V, which we can sketch anywhere here, will go up 1 and left 3. So that's what we're going to do. And again, I'm running out of room. I'm not planning ahead very well on this. Here, I'll just move my whole graph over. How about that? Okay, so the opposite of E just needs to go up 1 and left 3. Remember, we are attaching it end to end, so where the last vector started is where the next vector begins. Okay, so I have 3W, I have half U, I have the opposite of V. Let's put them all together and get our summation. I start where the first vector starts, and I end where the last vector ends. So that vector is your solution. Minus V. That vector goes down 1, 2, 3, 4 units if you want to check on your paper, and to the left 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So down 4 and left 9 should be that final vector. Make sure all vectors have initial points, dots, and terminal points, arrows. Okay, the next problem that we're going to do is we're going to talk about a position vector. A position vector is a vector that we're not floating around in space anymore. Sometimes it's hard to do calculations with vectors if they're kind of all over the place. A position vector will have a initial point at the origin. So all we do to take a vector and make it a position vector are we slide it. We slide it so it starts at the origin, and then you're going to see later on in this lesson that makes it easier to relate back to our unit circles and things we've done before and do calculations with. The formula for a position vector, and remember these kind of pointed brackets are what we use for vectors. That's how you know it's not a point, it's a vector, is the following: x2 minus x1, y2 minus y1. A good thing to remember with these is it is always terminal minus initial. So the point where your vector stops, that's what's going to be your x2, y2. And the vector where it begins will be your x1 and y1. So you want to just read really carefully here. So P is the initial point. So those are what we're going to use for the ones. And Q here is our terminal points. So that's what we're going to use for the twos. So for this problem, it would look like the following. Very quick and easy calculation. My x2, my x for my terminal point, -5, minus my x for my initial point, 8. My y for my terminal point, 6, minus my y for my initial point, -4. And so my final answer is going to be -13, 10. So what this means is the vector that starts at point P and ends at point Q is equivalent, same length, going in the same direction, as the vector that starts at the origin and ends at the point -13, 10. So we're describing an entire vector just by its terminal point, which is what we're getting here. And then we just always know that it starts at the origin if it's written in this form. Okay, the last few problems are just some quick adding, subtracting, and scalar multiplying with vectors. These vectors are written in position vector form again with those kind of pointed brackets here. First problem is 3v. I'm just going to write it out. 3 vector v, 6, -1, plus vector u. If you are multiplying by a vector, it's exactly what you would think would happen. We're just going to distribute in. It's making all of my movements, all of my horizontal and my vertical components 3 times as long. Vector u remains the same. And then we add together like components. So we're adding together our x's, which are our horizontal components. That gives us a 16. And then we're adding together our y's, which are our vertical components, -10, and that is your final answer. Next one is very similar. Let me get a different color. So we're going to do -2 times w, which is the vector -5, 0, minus vector v. Distribute my -2 in, 10, 0. And then I like to think of subtraction again as plus the opposite. So if we think of it as plus the opposite, we can add in a minute. All I have to do is distribute that negative in. So -6 and a +1, which would be the vector going in the opposite direction from what we started with. Again, add together your like components. 10 and -6 out front gives you 4. 0 and 1 gives you 1. Final answer. Next one, I have 7/2 u -2, -7 plus 1/2 v minus w. I'm going to think of it as plus the opposite of w. All right, so let's distribute everything in. 7/2 times -2 gives me -7. 7 times -7 over 2 gives me -49 over 2. You could get a decimal there if you wanted because it's exact. Distribute my 1/2 in. I'm going to have a 3 and a -1/2. And then distribute my negative in. I have a +5 and a 0. Add together all your like components. So add together all of my horizontal components, which look like x's here. So -7 plus 3 plus 5 is going to give me a +1. -49 over 2 and -1/2 gives me -50 over 2, which is -25. Plus 0, of course, doesn't change it. So that's our final answer on that one. Finally, letter D here. See if I can move that up a little bit. We're going to simplify on the inside first. The bars on either side here represent magnitude, which means our final answer will not be a vector, but it will be the length of that vector. So let's just start with filling in our vectors. Vector w is -5, 0, minus 2 times vector u, which is -2, -7. Distribute my 4 in, that's -20, 0. Distribute my -2 in so I can make it addition. That gives me 4 and 14. And then just add together my like components. So we are calculating the magnitude of the position vector, -16 and 14. Now if you were to draw this vector would be in quadrant 2. Remember, these always start at the origin, and it would go 16 to the left and 14 up. Because it's left and up, we can say that that's a right angle. So that would be our vector right there. The question is, when we see these double bars, it means find the magnitude or the length, which would just be in this right triangle picture solving for the hypotenuse. So you're going to see that this formula is actually just our Pythagorean theorem. It is the square root of the first component squared plus the second component squared. So if you remember with a vector that these components are like legs of a right triangle, the first one is the x along the x-axis, the second one is the height along your y-axis. That's where these are going to start relating back to our unit circle eventually. That could be helpful. All right, so 16 squared and 14 squared. Let's see what that gives me. That gives me the square root of 452. Let's see if that breaks down. It does. It breaks down into 4 and square root 113. So final answer, if I break down that radical, is 2 rad 113. And that's the end of the first half of our 7-4 big ideas. We will finish the other side of this worksheet tomorrow. You guys have the rest of the time in class to either watch the next Edpuzzle video or begin working on your Math Excel assignments. Math Excel is all due on the 25th, which is this next upcoming Sunday by 11:59 p.m. Talk to you guys tomorrow.